Hello, this is Mrs. Taylor, and I just want to introduce you to the next assignment that you're going to be working on. On one side, you should see this. It is a review of point slope form. And so in this first scenario, it asks you to graph the line with the slope of -3 that contains the point -2, 4. And so in the first step, they want you to plot the point. The second step, they want you to use the slope to figure out your rise over your run. And then after you do that, you connect the two points that you create with the straight line. So fairly straightforward. If they give you the slope and a point, you can graph the point first and then use the slope. The next problem asks you to first write an equation and then just write an equation. So it says write an equation slope-intercept form for the line that passes through the points -6, -6, and 2, 10. To write an equation in slope-intercept form, you need the value of the slope and the y-intercept. That's why it's called slope-intercept form. And so to find the slope, first you use the coordinates in the slope formula. That's step 1. And then after you have your slope, then you can choose one of your points. It doesn't matter which point, either one works. So you choose your point, enter it here, and then your first step is to take that and put it in the point slope formula, because you chose a point, you found the slope. If you put in this formula, it's fairly simple to then distribute and then add this number, and you'll get slope-intercept form. And so that's one of the nice things about point slope form is when you're given 2 points or a point in the slope, you can use that formula and then quickly move to slope-intercept form. So that's the front of the sheet. If you flip it over, you'll see some application problems. And so we are going to look at number 1 in this video together. Alright, so in number 1, it says the number of students in a school has been increasing at a constant rate. The table shows the number of students in the school for certain numbers of years since 1995. And when I look at the table, in the first column, it's years since 1995. In the second column, it's the number of students. So this would be your independent, your x, and this would be your dependent, your y. And the first thing they say is write an equation in point slope form that represents this linear function. And so in order to write point slope form, I need a point and the slope. Well, I have 3 points because that's what a table is. It's a set of coordinates. But I need the slope, and so I can follow that example on this sheet where I had 2 points and I was able to find the slope using the slope formula, so this middle section here. And so I can choose any 2 points. I'm just going to choose the first 2. So this would be x1, y1, x2, y2. And to find slope, you would subtract the y's on top and subtract the x's on bottom. And it doesn't really matter what you choose as your x1, y1, x2, y2. I can make 0, 118 my x1, y1, or I can make 5 and 124 my x1, y1. Doesn't matter as long as you subtract your y's on top and your x's on bottom. And so when I subtract, I get -6 over -5. And since the top and the bottom are both positive, then I can rewrite it as just 6 over 5. So that would be my slope. And then to get point slope form, I'm halfway there. I got my slope, now I need a point. And I can choose either the top point, middle point, or the last point. Doesn't matter. I'm just going to choose the first one because it's easiest, because it's first. So point slope form is y minus y1. So that would be y minus, and then my y value here is 118 equals m. Well, that's your slope. So here it's 6/5. And I'm going to write it with a slash like that, just to save space. And then x minus my x1, which in this case the point I chose is this first one, which will be 0. And so that's point slope form. It's that straightforward. Choose a point, find the slope using the slope formula, put it in. And if you can't remember the formula, it's on this paper. You use it right here. Y minus y1 equals m times x minus x1. The next thing says write the equation in slope-intercept form. So this is the steps they took here in this area. We would distribute the 6/5. So 6/5 times x. Hold on, let me write my 6/5 times x would just be 6/5 x. And then 6/5 times 0 would just be 0. So I could write plus 0 here, or I know 6/5 plus x plus 0 is just 6/5, so I don't have to write it. In order to get slope-intercept form, y has to be by itself. So my last step would be to add this 118 to both sides to isolate that y. The negative 118, positive 118 cancel, and that leaves me with y on the left side. And then 6/5 x plus 118, well, those aren't like terms, so it just stays 6/5 x plus 118. See, y is by itself. Y equals mx plus b. It's in the correct form, so that's slope-intercept form. Again, all you do is distribute and then add or subtract whatever that y1 was. Alright, last question. Assuming the rate of change remains constant, how many students will be in the school in 2010? Well, if you look, your y values weren't written as years. It's years since 1995. So if it's 0 years since 1995, this first row is 1995. And then I would add 5 to 95 to get 2000. Add 10 to that and you get 2005. So if I'm following that pattern, it would be 15 years since 2000 or since 1995. Now, if you look at the table, you would have realized that there is a constant change here in the y values of 6 each time. And so if you follow that pattern, then the next entry you would just add 6 and you would get 136 as your number of students. Now, that's not the only way to do this. We have an equation here, so we can use that equation. We can take the value of x, which in this case would be 15, and plug it in to the equation to get your answer. Now, fractions can be a little tricky. Luckily, we can use our graphing calculator. So 6/5 in the graphing calculator would be parentheses 6 divided by 5, top divided by bottom. And then if I wanted to continue to evaluate, I have 6/5 times 15, so I'd have parentheses 15, and then it was plus 118, so plus 118. And my calculator will evaluate that for me. Now, we knew from the table that we had a pattern there, and so we could just use that pattern to extend it to get 136. But this is how you could use your equation to get that answer. So either way, it would be 136 students that would be in the school in 2010. And so that's how you can use point slope form to help you problem solve with linear relationships.